Hello, everyone. I'm Matthew Huang. I'm here to introduce Kevin Liu. He is a software engineer. He's worked in big data infrastructure at Stripe. He's an Apache Iceberg committer and enjoys contributing to open source projects. And his goal is to lower the barrier of entry and improve developer experience for big data infrastructure. And with that, Kevin, I will let you take it away.
Thank you. Thanks for that introduction. Good morning, everyone. Thanks for coming in and joining the session. Very exciting presentation today about Iceberg, the ecosystem, the catalogs, and everything. We're going to do like a slow ramp, just in case folks are coming in from different contexts and backgrounds. Let's get into it. So today's talk is going to be all about Iceberg and its catalogs. And a little bit about me. Thanks for that great introduction. I'm just going to add some color to it. So I'm originally from New York City. I grew up in Queens. I went to Northeastern for school, and then now I'm currently in Seattle. I used to work at Stripe on big data infrastructure. Was there for 3 and 4 years. I'm also an Apache Iceberg committer. So what is Apache Iceberg? You've probably been hearing about Apache Iceberg a lot, especially in the last couple months. It's been hugely popular in the ecosystem and the industry. But I'll try to break down what exactly it is and what exactly I think it is from like my own mental model. And I just got this sentence from the website. So Apache Iceberg is an open table format for analytic data sets. And let's break that down, what that means. So the word open in this case, to me, it means that Iceberg itself is it's the opposite of a closed, which means there is a proprietary database, proprietary code base somewhere. Open means the Iceberg specification, which is a document you can access, anyone can access, to build a working model of something that works with Iceberg, which means anyone can build it and anyone can integrate with it. Table format. So the word table format, I think table is like a table in the database sense, as in like a collection of files, just a collection of data somewhere. It's almost analogous to file formats, which we're used to, such as like CSV, Parquet. So it's just like one level of abstraction up from the file format. Analytic data sets. So there's a distinction between kind of what is the analytical world and what is like the transaction world. So even in databases, there are like two different types, right? There's your transaction database and there's your analytical database. And the reason for that is the different trade-offs. You want your transaction databases to be very fast, to be very durable. If I was running a shop on the internet and I'm getting a ton of traffic, I want all of that to be recorded fast and durable. But on the other side, if I'm on the analytical side, I just want to calculate numbers. So that kind of transaction is not critical to me. So I'm, trading off some of that piece for some other piece to make it faster for me to run. But with all of that said, I think the way that it works is, we're bringing in database functionalities to the object store. And Apache Iceberg is native to like the cloud storage. So like your S3, your Azure, your Google storage, you can use Iceberg on top and use your favorite engine to now work with data. So that's the way I think about it. We're going to go like a little bit in depth on all the components and like how to work with it. And I hope after this presentation, you can take away with like, here's how I can get started and here's how I can work with it moving forward. One of the big components of Iceberg is the need for a catalog. And today we're going to talk about that. So we're going to talk about what is a catalog, why do we even need it, and how is the catalog used in this iceberg world, right? And when I say the iceberg world, it really means iceberg plus all your analytical engines. Like, how does it work um, in in conjunction with all your favorite engines? Okay, so what is a catalog, right? The word is vague in the way I see it. Like, a catalog, it just one of those words that can be overused for a lot of things. The way I think about it, a catalog is just a list of stuff, right? Like a book catalog is just like a list of books somewhere. So, in that sense, an iceberg catalog is really just a list of iceberg tables. I can go to the catalog, look it up, and say, okay, well, what are all my tables? And then the catalog gives me all my tables and say, you have a table named foo.bar, and it's over here. Um, and yeah, like the location of my tables, the catalog says, here's where your table actually is, right? I was saying that the iceberg is cloud native. So like if I'm storing everything on some file formats on S3, my catalog is the one that's telling me, hey, go to this specific location on S3 in order to start reading your table. Here's where your data is. And, it's just a good way to like organize your tables, right? Imagine if I have thousands and thousands of tables. Catalog gives me a way to, provide some structures to it, right? I can say, through that bar, or I can say this is data specific for marketing. So that I can say marketing dot blah, blah, blah. Okay, so why do we even need a catalog, right? Um, there are a couple reasons, some technical and some more for kind of the developer experience, I would say. Number one, it's a source of truth for tables. So, your table only exists in the enterprise setting. Your table only exists if it exists in the catalog, right? Because we don't want anyone to go directly to S3 and read a S3 path as a table. You're able to do that, but this is just a way to provide structures to it. So that if I want to read a table, I better register that with the catalog in order to say, here is where my table is, and then it's a way to tell the rest of the world who's working with this catalog that here's a table that exists. And we already talked about this a little bit. It abstracts away the details. So, if you work with Parquet tables or even Hive tables, you know that like a popular way to access is like through the raw S3 path. And sometimes that's not what you want to do. It's either not performant, there's no security standards. There's a lot of reasons why you want to abstract away details for the users. So like, for example, if I'm like, trying to analyze some data, it's a lot easier for me to go to like the catalog and ask, okay, what is my marketing data for this specific segment versus like trying to figure out that exact S3 path. It's a good separation of like where the data is physically stored and the logical representations of it. And the last thing, and this is pretty important, which is like it provides a database semantic to Iceberg. And I pointed out to ACID, and it's kind of a term that's been thrown around. But what it really means is that, you know, um, at the base level, like when I go and update the data, there's certain guarantees that I want, right? When I update it, I want to make sure that the update happens, and either it all happens or it doesn't happen at all. And like if during the update, no one who's reading it will be seeing partial data, will be seeing incomplete data, will be seeing like just weirdness coming out of this. And this is actually, before Iceberg, um, this is not the case. There's like a lot of weird issues where, you know, previously S3 was not, what's the word? It was not, I think it's called read after write consistent, which means like sometimes you just write data in and like it takes a while to come in. So that you don't know whether or not like things are actually written as is at the time that you're reading it. So like a facet of this is you have to write a success file to say, okay, I've written all my files already. Let me write a success file to say that, if you see the success file, everything else has been written. And that goes away with the catalog, because the catalog piece is where you tell to say, hey, here's all my update, and the catalog does a swap to just say, okay, here's the old place, here's the new place. Let me swap it, so that that single atomic operation will change the view for everyone else. So then you have this like consistency guarantee. So that's the best way I can explain this. And obviously, there's a lot of like other um, functionalities and features on top. If you want to read more, I suggest going to the docs for Iceberg, and it goes into greater details about this. Okay, so we're going to talk about how the catalog is used, right? And you have this concept called catalog. It's you kind of understand the basics of it, but how do you take this thing and apply it to like what you're doing right now? And typically, how this works is like your favorite engine, right? Like Spark, Trino, or your favorite vendor, all have this concept of a catalog. Either they expose it or they have like an internal representations of it. So, some familiar terms can be like, Hive Metastore, that's a catalog. Uh, AWS Glue, that's another catalog. If you're on like the newest and latest thing, like the Iceberg REST catalog, right? And the way you will work with this is you go to your engine when you're configuring it, you say, okay, here is where my catalog is. And then you provide kind of that connection between your engine and your catalog so that the engine knows, because it's already integrated with this open source code, to say, okay, I know here is where the catalog is, and here are all the operations I can do for a catalog. So, I can, now when I detect that it's using that catalog, I can just call the specific function. So, just given an example, if I've already set up a catalog with my Spark, uh, and my catalog has a table called food.bar, I could just do select star from food.bar, and then Spark would know to go to the catalog, fetch the location, come back to Spark, and then go to that S3 location and like get all the data. So that's all done in the background. And like in order to use the catalog, you just need to provide that connection to your engine. Okay, so now we're going a little bit deeper into the different types of Iceberg catalogs. And there's several for historical reasons and just for just being able to use across a broader ecosystem. I already kind of insinuating on some of them. So HMS here is called Hive Metastore. It's used because a lot of enterprises were on the Hive Hadoop stack, and Hive Metastore was an integral part of that. And when Iceberg first started, it was kind of a latch onto the Hive Metastore and a replacement, and eventually a replacement for that. Glue and Dynamo are both AWS products. They can be used as as a Iceberg catalog as well. We have Hadoop, and we'll talk about why there's a star next to it. We have like SQL and JDBC catalogs. We have a in-memory catalog, and we have a REST catalog. And we're going to go in and talk about each one. So Hive Metastore, HMS. So the Hive Metastore, if you're ever running Hive, running Hadoop stack, running kind of like enterprise data platform with this, you'll hear this term a lot. What it is just in that ecosystem. It also has this concept of like this metadata service, which provides kind of a place to read and write metadata. So like for a specific table, like metadata about that table is all here. Um, and you can either have a standalone metastore or it's embedded. But the way that any engine kind of corresponds with Hive Metastore or like integrate and talk to is through the Thrift protocol. which is in itself, it's analogous to like HTTP. So it's just a different way, a different protocol to talk with the service. Uh, Typically, when you use the Hive Metastore, uh, you co-locate like Hive tables and Iceberg tables in the same Metastore service. And the word co-locate here is a little weird because Hive Metastore was made for Hive and the Hive ecosystem and this quote unquote Hive tables, right? And a popular way to use Iceberg is to say, okay, now I'm migrating from Hive to Iceberg. So then I want to also use the Hive Metastore for my Iceberg table. And this is how kind of Iceberg first started. And so there's like a known path to work with this. And the way it works is, some tables will be Hive tables and some tables will be Iceberg tables. And there's like a property field that represents which one's which. So essentially Iceberg hijacks Hive Metastore and say, okay, well, I'm going to reuse this component, but it means something else. And usually like it's around because you're transitioning from Hive to Iceberg where you already have Hive. Um, yeah. Okay. So Glue, DynamoDB. I put them together because they're both like AWS services, but they're distinct. They're two different things. AWS Glue Data Catalog is one of the AWS services which provides this kind of like metadata and cataloging functionality. Um, AWS Glue is kind of a loaded term because there's like many services around data within AWS Glue. So the Glue data catalog is that one piece of technology where you can see like where your metadata is, where your table is, and it works very well within the AWS ecosystem. So it integrates with like Redshift, Athena, EMR, and its initial functionality was to provide this cataloging service um, for those engines. But because of this like kind of open Iceberg world, Iceberg is able to use AWS Glue catalog for its own operation as well, similarly to how it's using it for like the Hive Metastore. One thing to know about the Glue data catalog, and I found out about this recently too, is that it's region specific, which means, depending on which AWS region you're on, you're seeing different views of the catalog. So if you register a table on US East 1, you're not going to see that table on US West 2. And I don't know what the historical reason is, but that's just the way it is for the Glue catalog. And then you have the AWS DynamoDB catalog. This one's interesting because at its core, the DynamoDB is just providing kind of a key value store, a database service. So I added it here because it's an AWS service, but it's very much closer to the SQL catalog that we'll discuss. Okay, and this like kind of confusing term called Hadoop catalog, which I think the right word is the file system based catalog. And the way it works is that usually catalogs require a service, right? It requires some kind of service to say, here's where all my data is, and the engines can interact with it. The Hadoop catalog kind of says, okay, I'll do away with that. Whenever um, my catalog is actually on the file system. It's on S3. So like whenever you try to like look up a table, actually just like there's no service behind it, just go to this specific thing on the file system and look it up. And there's a disclaimer here about the Hadoop catalog, which is that it's unsafe for object stores and local file systems. And this unsafe means a very specific thing. It means that in the event for multi-reader or multi-writer scenarios where in Iceberg you can have multiple engines all writing to the same table, all writing at the same time. When that happens, there's a race condition, and the Hadoop catalog cannot figure out how to resolve that conflict, which means you can be overwriting data, and the engines will know about it, the tables will know about it, and you end up in the scenario where the table is in an inconsistent state. And which is like, one of the reasons why a catalog is important is to like make sure that you have that mechanism to work with multi writers. Um, and the way, it's unsafe, but it's safe when you have this concept of like atomic swap, such as like in HDFS, which means then, you can do one update, lock the update, do your own update, and then release the log. So then the next concurrent writer will come and just kind of work on that, and you're working in lockstep. So that's a way to provide that uh, guarantee, I guess, and make it a lot safer. Okay, SQL. So this is kind of analogous to like the DynamoDB one. SQL here means it just means database. JDBC means like database connections. So any SQL-based service or any database connection you can use as a catalog, and it should just work because there's an implementation of the catalog, which is read and write to a database. So this really allows you to bring your database and make it act like a catalog. So you can bring your DynamoDB service as a database and use it as a catalog as well. Okay, this is one of my favorite ones, and this is like when you're like working with it, it's one of those things that you just appreciate. So what is a in-memory catalog? Technically, we don't. It's not like something a different implementation. It's just a special use case of the SQL catalog. Um, in databases such as like SQLite, there's a kind of a concept of a in-memory database, which means you keep all your information in the computer's memory, and this has a lot of interesting um, and very, I guess, developer friendly uh, usage, right? Sometimes if I'm trying to use Iceberg or a catalog, I don't want to connect to my catalog, or like, if I'm starting from scratch, I don't want to have to set up a catalog service before I want to use Iceberg. I just want to like, run some code and it just works. So this is a way to like say, okay, well, I don't need to bring my own database. My own database is actually in memory. So this should just work out of box on my computer. And the thing to know here, because it's in memory, it's not durable, which means it like after you exit the program, everything in your catalog is lost, which is fine in some use cases if you're just like kind of spinning up something just to work with Iceberg. Um, it just provides a nice way to like quickly spin up a catalog if your use case doesn't require it to be ephemeral. And then finally, the newest and greatest, the REST catalog. And REST here means like, RESTful service, like HTTP. So there's a REST specification, which means there is a set of rules somewhere that says, here's how a HTTP endpoint will look in order for it to look like a catalog for the engines. I already mentioned it communicate over HTTP, which is kind of a universal language because you can be in any programming language and there's a HTTP packet, which means that it doesn't matter which language you're in, you're always going to be able to communicate with this REST catalog. It has this concept of like bring your own catalog. So the REST catalog is just really like a REST endpoint, but then it accepts HTTP requests, but it has to kind of persist that and work with it somehow after it receives that request. So this is where the server works with its own implementation of a catalog to do that translation, which is where you can bring your own. So you can do a REST catalog with a Hive metastore as the backing, or a SQL catalog, or Glue, or whatever you want. And it's supported by many engines. So when this first started, everyone supports like the Hive metastore catalog or the SQL catalog and this and that. And then if you're creating a new engine, you want to work with Iceberg catalogs. Now you have to integrate with like all of the catalogs I said above. But a better way is to just say, okay, I will only integrate with the REST catalog as an engine, and I will make sure that like everything, all the other catalogs are like REST based, right? So I have this like REST layer in between that does the translation. So it solves that end-to-end problem where like you have in engines and in catalogs, and each want to talk to each other, you can just talk through the REST interface. And then because it's a REST server, you have all the controls of running your own service, which means there's a lot of like optimizations you can do, server-side optimizations, like in a case where you have multiple concurrent writers, there can be some duplication, and the world is yours. You can do whatever you want in that case. Okay, cool. Well, sped run through that. We do have a Q&A at the end, so if you have questions, we can answer those later. But I have a demo, and hopefully this works. Let me reshare my screen for the Jupyter Notebook. Okay. Is this too small? Okay, that's pretty good. Okay, so I'm just going to, everything that we talked about, just gonna add some code to it. It's not the best because there's still even when you have a catalog, there's a lot you can do with it. But this is just a way to show you, how can you, like right now with Python and with PyIceberg, get started with a catalog today. And this Jupyter Notebook is also available online. I can post the link later, and the presentation as well if you want to see it beforehand or afterhand. Okay, so there's some setups, and I already kind of mentioned how to do that. So I'm just going to do that right now. Okay. So we're going to demo all of these catalogs, and for some of these, or actually a lot of these, it requires a external service to be run in order for this to work. So like Hive Metastore requires a Hive Metastore service. Glue requires that you're able to talk to AWS Glue service. Hadoop is file-based, which it's not currently available in PyIceberg yet, so we're not going to show that. There's SQL catalog, which we'll just use the SQL database that's on my laptop. Same thing with in-memory, and then REST. So really, we need the Hive Metastore and the REST service spun up, which is there's this Docker command, and I provided a link to that, which will just spin up both of those services on my local Mac. And then for Glue, you need AWS CLI set up with the proper permission. And then, it's a lot of work to get that set up. So, just find an article on how to do that. Okay. So I think the services are up. Okay. So let me just do this too. All gone. Okay. So let's see. First of all, you want to install PyIceberg, and you want to also install some of the extra stuff that comes with different catalog implementations. So this Hive just brings in all the Hive dependencies for PyIceberg. Same thing for Glue, and same thing for SQLite. Okay, I think it downloaded. Great. Okay, so Hive Metastore catalog, or HMS. So the way this works is, there's a class in PyIceberg for catalogs called Hive catalog, and then you provide all the parameters that is required to connect to this catalog. Oh, 1 second. Looks like my service isn't running because I have something else running. Okay, 1 second. Let me restart that. Okay. Cool. Okay, now it's running. And the way this works is you just provide the URLs to connect to them, and then there's if you go to this link, it has all the URLs. So for like a production use case or for something that's more custom, just go look at the URLs, the URL for this, and figure out the configuration to make this work. Right now, what we have is we tell this class where the Hive metastore is. And in this case, it's in my localhost on a Docker somewhere running on port 9083. So then gonna run this. Hopefully it works. Okay, so I guess it run. And then, I'm just gonna, oh, what's happening? It already exists. Okay, so I think that's because I need to restart my container because it has some other state. Yeah, I was running this before, so you can't create the namespace twice. So let me just restart the container and then we can rerun this. Okay, cool. I think it's back. Okay, so let's rerun this. Oh, okay, because it's not here yet. Okay. Okay, great. It didn't work before because Hive metastore wasn't set up yet. Okay, so we had a namespace in there. We added a new namespace. This is just a way to show that it actually works when you connect to it and you do something. If you want now that you have a catalog, you can do whatever else you want with PyIceberg and Iceberg. So I can create a table here. I can do like analytics on here. Look at the getting started guide for PyIceberg, and you can do the rest. Okay, so if you have a glue catalog, as I mentioned before, glue is region specific, so you have to be able to connect with it. And I already set up the AWS credentials, so hopefully this will work. Okay, yeah. So I already created something in my namespace before. I think I have a one on East one. Okay, well the one on East one is just empty. Cool. And then, oh yeah, so the Hadoop catalog is in here, but there's an issue out for it to be implemented. And then the SQL catalog. Okay, so same thing. We're going to use SQLite. The syntax here is we're going to actually store the database in a file somewhere. So this is kind of a SQLite syntax where I say, okay, I'll create a file on disk to say where my catalog is. So let's do that. We created a namespace there. And then for fun of it, we're just gonna go look at this on my local file system and see what's in there. Okay, well, it has this. Let's see. Yeah, so there's 20 kilobytes of data in there because we just stored a namespace. So you can interact with this database later on as well. It's persistent. If I turn off my Python process, it's still there. I can the next time I use it, I can just read from the database. The namespace will still be there. It's just a nice way to persist data. And if you don't want to persist data, you don't want to write it to this somewhere, SQLite has this concept of an in-memory database, which means you provide this and it says, okay, I'll just start something in memory. And then when the process terminates, this will be gone. And it just wouldn't persist data outside of this session. Okay, and then REST catalog, same concept. There's a service running somewhere. It's actually running on my Docker container, and it has the port 8181 open. So I'm just going to connect to it, and then I'm going to read it. And then for fun, let me see if I can access it on. Namespaces. Okay, I guess I have to reshare my screen for this to work. Yeah, let's just reshare the screen. Okay, I just want to show, I guess this doesn't show the URL, but I just want to show that, now I can access to the REST server, and this is the REST server. So, this is v1 config. we want namespaces, and then I can do namespaces foo, and it shows me all the things that, what a REST server has on file for this. It's kind of a bummer you can't see the URLs, but I can share that later. Okay, back to our notebook. Yeah, well, there's this other one where I was testing around and seeing if I can create a REST server implementation in Python. It's in the GitHub somewhere, so if you want to play with it, run it. It's using Fast API. It's using PyIceberg in the backend. I'm not going to show it now just because there's a lot of setup, and I don't want to do it live. But that's kind of a demo of like all the different REST catalog implementations and a quick way to run them. And then let's go back to the rest of the presentation. Okay. Oh yeah, and go to this gist on GitHub. You'll see that notebook. You can run it yourself. Hopefully it works for you. Okay, I am going to talk about the REST catalog and why I think it's the best thing, and why I think if you're an organization and you're running all of these other catalogs, you should probably be using REST, and it's probably a good choice for you. Okay, so part of what we've discussed before is interoperability, which means this REST catalog should work with all of the other engines. So all the engines now are supporting different catalogs, and one of the most important one is to support for REST catalog. So Trino has one, Spark has one, all your favorite vendor is coming out with a REST catalog support. And this is just a way to solve that n times n problem I was talking about before. And the beauty of the REST catalog is that you can bring your own catalog. So you can say, I have a REST one, and then actually in the background is my has Metastore. And this is a way to decouple your infrastructure to say that I'm not going to expose the detail of my infrastructure, such as this is a Hive Metastore, to my external vendors or to my external engines. By running this REST service. Plus, because you're running the service, now you're able to extend it to say, now you can do data lineage or data tracking, or seeing who's reading what and who's writing what. And a lot of observability functionalities on top of the catalog. It also you can also use it to avoid vendor lock-in, and this is pretty important. And vendor lock-in means maybe I'm on AWS Glue and I want to use another vendor, right? I want to use Snowflake. Well, how do I move my AWS Glue to Snowflake? Typically vendors have integrations, but then it's still that end-to-end integrations. You got to wait for it. You got to make sure that it's supported well. So a way to avoid that is you just say, okay, it's not a Glue service. It's actually a REST service, right? And your vendor will support the REST service. And then you can say, okay, well, I'm just running that, right? So it's a nice way to decouple the infrastructure, make it so that everything talks through this one specific kind of API, right? This REST API. Yeah, and I wrote an entire Substack blog about this. So if you want to read more, it's all there. Okay, we're going to talk a little bit about ecosystem because this is kind of very important, and it's very up and coming, and this is where I think the world will go in 6 months to a year. And you probably heard of a lot of these just because they're very new, and there's a lot of activities in this space. So everyone is coming out with a catalog, is a TLDR, and then everyone is integrating with a catalog because Iceberg is a open specification, which means your Iceberg table, wherever it is, should be able to interact with whoever that supports Iceberg. Which means, my Iceberg table should work on Snowflake, should work on Databricks, should work on AWS, Google, Azure, anyone who supports it, right? And we're seeing the support kind of coming in throughout the industry more and more, right? I just saw Amazon Firehose just announce Iceberg support. So now you're adding more and more to the ecosystem. And speaking of ecosystem, Snowflake has this kind of product slash catalog, I guess, called Polaris. There's also Apache Polaris, which Snowflake donated to the Apache Foundation, which is an implementation of the REST catalog that we talked about. So right now you can go to Apache Polaris, run that project, and now you have a REST catalog API and REST catalog server. Same thing, Databricks has like Unity catalog, which they're kind of coming from another angle. They have their like kind of Delta table. It's also a Linux Foundation project, but it's analogous to Iceberg table. It's like another table format. And then Unity is their catalog for Delta. And there's functionalities now in Unity where it's integrating with Iceberg. So right now I can expose Unity catalog as a Iceberg REST catalog and read it the same way. Same thing with AWS Glue. I already talked about this. It's just AWS's catalog. Google has BigLake, which is like their version of a managed Iceberg table. I'm not actually sure what Azure has, and it's because I don't work on Azure a lot. But if anyone knows, please let me know, and I'll update the slides. And then, your favorite vendors: Starburst, Confluent, Dremio, Single Store, Oracle. Anyone who is in this space is trying to support Iceberg and bring in data into this ecosystem, which means at the end of the day, everyone wins. And I think it's worth to pay attention when you have a company like Oracle getting support for Iceberg. It's like a big thing. Okay, recommendations. So just brief recommendations on all the catalog stuff that you heard. SQL catalog is great for a prototype. You already seen. Either it's in memory or it's just in a durable file somewhere. It's just a quick and easy way to get up and running. If you're in a production or prototype setting, you can also go to your favorite database vendors like RDS or Aurora or Neon or whatever, and just get an HTTP URL for your database and then use it for your SQL catalog. REST is great if you're in a production, if you're in the enterprise and production setting. Gives you all the benefits of the other catalogs and then some, specifically for interoperability and extensibility. Only use Hive Metastore if it already exists. There's no reason for, if you're new to this, to start with a Hive Metastore. In the background, Hive Metastore creates a database. So you might as well just create that database yourself and use it as the SQL catalog. And so you don't have to like have this another layer of indirection, especially if you're not in the Hive ecosystem. And then, only use the vendor solution if it's a two-way door, which means, or if you know that it's a two-way door decision, which means make sure that you're able to get out of that vendor specific situation, right? So, Iceberg, the promise of Iceberg is that you're able to read that one Iceberg table wherever because it's an open specification. But if you're locked into a specific vendor, that means you're only able to read from that specific vendor. And REST catalog might be one of those solutions that gets you out. So like if you're in AWS Glue and you want to bring your AWS Glue data to your like on-prem, you can slap a REST catalog on it and then just use it as a REST. And that's it. I hope this is a good way to get started with Iceberg catalogs. There's a lot of other pieces to Iceberg and PyIceberg. So check out the docs if you're interested. We're looking for contributors as well on the PyIceberg side. I think it's a great project to be in because it's both Python and Iceberg concepts, and there's a lot of work to be done to make this happen. And yeah, if I'm also doing data infra consulting, So if you're, have trouble with Iceberg, open table formats, anything big data, you can feel free to hit me up and we can chat. And then, I threw my LinkedIn and Substack in there for people to check out. And cool. And then there's some additional reading, some cool links here, very helpful links. And we can take questions. Hey.
Hey, Kevin. Thank you so much for giving that awesome presentation. Doing live demos are always a bit of a challenge. I always have a couple things that go a little awry, but you fought through it and, ended up having a pretty successful demo. First, I would like to invite the chat, I guess. If you have questions, please post questions in chat or in the Q&A, and we'll get to those. While we wait for a couple questions to come in, I guess, what kind of got you into working with Apache Iceberg and kind of doing a lot more of the open source projects?
Yeah. So I accidentally run into this at work. We were just using Iceberg, and we were running the Hive stack. Iceberg was like this cool new thing. We're like, okay, great. Like all the problems that we have can be just solved by this, and it's there's like a great open source community behind it. So as we're working with the technology, we're just working with the ecosystem as well. And then it's my first foray into like open source, and kind of just working with people in the community has been like very rewarding. So then just kept going, and then the PyIceberg project came out, and I always had a love for Python because a lot of big data is written in Java and Scala, and I still have a love for Python. So this is like kind of a best of both worlds for working in Python, but also working with the concepts I already know. And did I mention community? Because the community is awesome.
Yeah. No, I think I've joined like 3 or 4 different Discords for like data engineering and data science, and I'm always like trying to get as many people kind of involved as possible and trying to see what's kind of going on in the data world and just trying to connect with people. That's one of my favorite things to do.
Yeah, no, it's great. I think like through this community, I was able to meet a ton of people, get a ton of help to help me with my work and also open source work. So now, it's also me giving back to say, hey, if you want to get started and you want to start working with Iceberg or PyIceberg, come join us. I guess I've opened a bunch of like good first issues. There been a lot of kind of people just coming in to say, hey, I want to help work on this. That's how I got started too. I worked on like a bug that was like a one-line fix. But then it was just like, you do that one-line fix and then you do something a little bit bigger and then a little bit bigger and then you just keep the ball rolling.
All right. We've got a couple questions coming in here. Those links that you have up, the additional readings, could you post those in chat for some of the people? I don't know if you have access to that.
I'll do one better. I'll post the entire deck on the chat so you can take a look at that. Yeah, pretty sure it's open to the public. And if there's a way for me to post this and actually you have links to the gist through the deck. So
yep.
We can try to send the deck out later.
Sure.
If that's a way to do it.
From Sean, how do you see PyIceberg being used in enterprise analytics stacks and or in medallion style architectures?
Yes. So I think PyIceberg is an interesting situation right now where, like I mentioned, traditional like big data stack is all written in Java and it's deployed alongside with engines, right? So, most people use Trino or a managed or Spark or a managed version of the both. PyIceberg comes in in a couple of different places. Number one, I would say, is for like observability, and this is where I first got into it. Say you're running this entire stack on your enterprise, and you're able to read write to it, you're able to do analytics to it, you're able to do your ETL with it. Uh, but like sometimes as a analyst or data engineer or infra engineer, you just want to say, okay, like what's going on with my table, right? I have this table foo.bar. I want to know about it. Like how much data is in there, how much, what the partition looks like, what the sort looks like, where, do I have too many small files? Do I have this and that? And it's just like, it's a good way to like go look at what your table is actually doing. And this is where like the power of like Python comes in, right? I could just do pip install PyIceberg. I can set up my connection to the catalog as you just seen, and then I could just like run it as a CLI or run it as a Python program to do that calculation for me. So like some of the things we've done is like the growth of this table, right? Like I want to track the growth of this specific table over time. Is it ballooning? Am I doing garbage collection? And it's just like a nice way to do this, because the alternative is you got to like spin up your engine to do one of these reads, or like we did back at work. It was like we wrote like a Scala wrapper, and every call takes like 5 seconds. So PyIceberg is just like a nicer interface to work with your iceberg tables.
Sure. We do have one in Q&A from Sai. Why is Hadoop catalog not supported in PyIceberg? We're currently using Hadoop catalog in our production and haven't faced any problems yet, but is it recommended to migrate away from the Hadoop catalog?
Yes. If you're in a production setting and you're using a underlying file system that doesn't have atomic swap, you won't see the problem per se, but things would just go weird. Like if you ever have multiple concurrent writers, some of your data might just be gone, but then it's not an error. You just like kind of one just overwrites the other and you just don't know it. And this is the problem with like traditionally what happens with like the Hive catalogs, the Hive tables. It's just like sometimes these weird data engineering things just happen and you don't know until you go and investigate like, hey, why, like, where is my data, or why does this data look weird? If you really want to suss out the problem, test out a scenario where you have multiple concurrent writers and just keep writing, and you'll hit like an edge case where some of your data might be lost. So I would recommend to use another catalog, or I don't know if the new like S3 like put if absent will help in this case. Maybe it does, maybe it won't. But yeah, I would suggest to double check your file system, make sure it's compatible. If you have atomic swap, it's great. You don't have to worry. If you don't have it, there might be a silent corruption error sooner or later.
One from Tanvir, I guess two from Tanvir. What are the top two business impact of implementing Iceberg in an enterprise data warehouse project?
Yep.
And will you share the slide deck, which you did immediately after?
Yes. Top two. Okay. I would say the first one is like just general data engineering stuff, right? Like if you ever worked with like Hive tables, or just, if you ever work with like just file formats, things can go weirdly wrong sometimes, or like things just doesn't work the way you want it to work, right? And I think Iceberg provides this layer of features where you can say like, hey, I want to just sort my data, or hey, I just want to partition my data this way. And there's a whole section about hidden partitioning and partition evolution and schema evolution. Like all of these features are due to this like level of indirection provided by Iceberg for like files, right? So, if my business is like have growing data needs, right, and my analytics isn't running, I can try to partition it, I can try to sort it. There's like ways of optimization. And it's just like another way to add more features to your data. Number two, I would say, is that the kind of openness to it. The promise of Iceberg is that if I have one Iceberg table, I can read that to in any engine that supports it. So right now I can be using Spark, right, or a managed Spark. And tomorrow I want to try out Trino because it's great for analytics querying, it's super fast. Or you can say I want to try DuckDB for some reason, and to say, hey, I want to use DuckDB in a production environment with Iceberg, and it should just work. There's some kinks here and then because there's still kind of features coming in with all the engines, but that's the promise of it, right? Is that I write once, write it as an Iceberg table, and now whatever engines that support Iceberg, I'm able to read it. So like, what I just say about Amazon Firehose or like Confluent or like all these other streaming vendors, you can bring your streaming data directly into your Spark or your Trino, and it should just work, right? And that's very powerful because now you don't have to ETL your way to like access data, right? Your streaming data is not over here, and the only way to access it is to bring it over here. Everything should just work, and we're getting there. But I think that's a very powerful concept, especially in like the enterprise setting.
Another one in Q&A from Kevin. What suggestions do you have for someone who wants to start using Iceberg and get a firsthand feel for its value? Maybe some project ideas or other recommendations for where to start, and if you have some data engineering background.
Yeah, I would say the easiest way to start is to go to PyIceberg and look at the docs. And this is where I've spent a lot of the times just to make it easier, right? And we scope down the docs to like a very simple way to get started. Like a lot of big data infrastructure kind of assumes that you already have certain pieces already in place. So like it assumes that you have some kind of metadata service already running, like a catalog service. It assumes that you have access to like object store. We did away with all of that. We abstracted away all of that. So like right now you can go to PyIceberg, run a catalog in memory, which only requires you to pip install like some kind of SQLite, right? And you can use your local file system instead of S3. So you don't even have to set up that S3 connection. So, very scoped down, easy getting started guide. And then, as you go through the examples that's provided on the website, you can mix and match, pick and choose, right? You can say, okay, well, now instead of writing to my local file system, I want to write it to my S3, right? Or my Azure or my GCS. Or like now, instead of using an in-memory one, I'll create a new catalog service somehow and run that. So like, this is like a very ramped up, one step at a time way of like interacting with it. And the good thing about Python and its ecosystem is that like, there's a lot of analytical packages for doing this, right? So you can do like, you can use Spark or not Spark, Pandas data frame in conjunction with PyIceberg. You read the table back as Pandas, and now you can just do whatever you can do with Pandas, right? And there's Arrow as well. There's a bunch of like support and when you get the data as like a data frame on Python, the world is yours, right? Like you can install any package you want and run anything you want. So long story short, I recommend going to the docs. And if there's anything that's confusing as well, please submit an issue because that's something we're also working on just to get more and more people, one, experience PyIceberg, two, just learn more about Iceberg, and three, like if you want, contribute to the PyIceberg project as well.
Awesome, and I think that just does it for time here. So thank you again so much for your talk. Everyone in chat, please go back through and see what other talks are coming up. And again, Kevin, thank you. We have shared your LinkedIn here. People should be able to access some of the Iceberg documentation that you have with the shared link that you've provided. So awesome.
Great. Yeah, thanks for having me. If you have any more questions, feel free to reach out. My LinkedIn is there. My email is there. I'm on the Iceberg Slack channel if you want to join us. if you want to play around with PyIceberg, feel free to do that. And yeah, thanks for having me.
Yeah. All right. Bye, everyone.